have relied on the value of the first byte of a given IP address to determine the class of that IP address. And we have also learned if the class of an IP address is known, what is the network part and what is the host part. Subsequently, once the host part is known, we know how to calculate or find out the broadcast address for that network. Now, I am going to introduce the concept of subnet mask and explain how using subnet mask we combine that subnet mask with an IP address and find out the network part and the host part. Another use of subnet mask comes into play when we try to divide a network into smaller networks. What we call it as subnetting. Now when I say, going back to the concept of explaining how it is to be used, first thing is when we say combine a subnet mask with an IP address, what in essence we are doing is we are performing a binary bitwise AND operation. Many of you might be aware of the binary bitwise AND operation. For those who are unaware, let me quickly lay it down for you. So if you perform a bitwise AND operation between 0 and 0, the result is 0. And if a bitwise AND operation is carried out between 0 and 1 or 1 or 0, the result is 0. These two cases, 0 and 1, 0, 1 and 0, 0. And finally, if we carry out a bitwise AND operation between 1 and 1, the result is 1. So this is going to be the basis for all the calculations that we do in using the subnet mask with the IP address to determine the network part and the host part. In the scheme of classful IP addresses, each class is assigned a subnet mask, which we call as the default subnet mask. So class A is assigned a default subnet mask of 255.0.0.0, class B 255.255.0.0, and finally class C 255.255.255.0. There is a similarity with the structure of subnet mask with an IP address. Subnet mask is also represented in dotted decimal and is also 32 bits or 4 bytes long. So let us do a quick exercise of matching an IP address with the corresponding default subnet mask. In the first column, we have the IP addresses and the second column has default subnet mask. And we need to match the IP address with the correct subnet mask. So let us begin with the first IP address. And again, all we need to do is look at the first octet of the IP address, check in which range that value falls and determine the class of that, and once the class is found, look for the corresponding subnet mask. So if you look at the first one, it is 192. 192 falls in the category of class C because the class C range is 192 to 223. So this is the class C IP address. Now for the class C IP address, as we just discussed, the default subnet mask is this. So we will pair it up with this one. This goes with this. The next one is 70.234.179.82. Let's ignore the last 3 bytes. Just focus on the first byte. The value is 70 and it falls in the range 1 to 126. So this is the class A type of IP address, and hence for the default subnet mask for class A is 255.0.0.0. So the match for this is this. And then looking at the third one, the value of the first octet is 142, and 142 falls between the value 128 and 191. So it is a class B network, and for class B networks, as we learned, the default subnet mask is 255.255.0.0. So the correct answer would be like this. So this is how you should practice identifying the default subnet mask of a given IP address.